Everyone, in this video we want to talk about the integrals of tangent and secant. So in the last video we covered the formulas that are involved with the integrals of tangent and secant, and we're going to be looking at those in this video. So this is actually going to be our last video on trig integrals. We were going to do cotangent and cosecant, but everything that we talked about in the tangent and secant integral formulas can be also rewritten with cotangent and cosecant, since their Pythagorean identities are so similar. And of course the integrals are just negative, so just be careful of that. But we're going to be sticking with tangent and secant today, and we're going to be throwing the works at you. And we're going to have some returns of maybe your pre-calculus trig class, maybe stuff you wanted to forget, but it's coming back in Calc 2, so you've got some stuff to be excited about, I guess. And we'll look at that. We'll look at that today. And we'll be throwing 4 examples at you in our last video for the trigonometric integrals, but do not fear, we are nowhere near done with trigonometry yet. All right, let's get started. So the first example I want to look at is the integral of tangent x times secant cubed of x. Now, for this integral, we want to be looking at the power of the secant. So the power of the secant is odd. So what we are going to want to do is we are going to want to take a power of secant and leave it out at the end with a tangent. And then we'll put the rest of the secants into a parentheses. So that's going to give us the integral of secant squared of x times tangent of x, secant of x dx. Now this is easy because we don't even need to apply, apply any more. We just need to apply that Pythagorean identity, and then we're going to be all set. So we say that the integral of the secant squared of x times the tangent of x, secant of x dx is equal to the integral of 1 plus tangent squared of x times tangent x of and secant of x. Now actually, this Pythagorean theorem thing here was just a bit of a trick, actually. We don't want to do this, just because we have tangent here, but we set up the derivative here for secant. So make sure you're not doing too much work. This would be prepared for a u sub. Here we have a u here, and we have our du right here. So this would be the integral of u squared du. So don't even look at the Pythagorean identity. We can go straight into a u sub right from this integral. So just be clear for that. Sometimes you can make this a lot easier on yourself. Just look for the derivative of the function, right? It's the reverse chain rule. So that's the way that works. So this gives us a substitution of u equals secant of x and du equals tangent of x times secant of x dx. That gives us the integral of u squared du, which is of course 1/3 u cubed, and then we have u equal to secant, so we get 1/3 secant cubed of x plus c. Okay, so that was easy enough. Let's move on to the next example. So for this example, I would like us to integrate tangent to the 5th of x times secant cubed of x dx. So what we're going to want to do here is we are going to want to look at the tangent power. Since the tangent power is odd, we want to be looking at this guy. So what we want to do is we want to separate one single tangent power for us. So we're going to separate a single tangent power. This is going to give us the integral of tangent squared of x, quantity squared, times secant squared of x, times tangent x, secant x. Now right here, we've actually got the options for both derivatives, but we are going to want to look at this guy here, because we are going to turn this guy into a secant by using the Pythagorean identity. So this gives us the integral of secant squared of x minus 1 quantity squared times secant squared of x, tangent x, secant x dx. Right here, now we've got our du here, and we've got our u right here. So this gives us a u of secant of x and a du of tangent of x, secant of x dx. So now all that's left is to plug in and do some algebra. This gives us the integral of u squared minus 1 quantity squared, times u squared du. And that gives us the integral of u to the 4th minus 2u squared plus 1 times u squared du, which gives us u to the 6th minus 2u to the 4th plus u squared du. Now we apply that reverse power rule, giving us 1/7 u to the 7th minus 2/5 u to the 5th plus 1/3 u cubed, substitute back in our secants. That gives us 1/7 secant to the 7th of x minus 2/5 secant to the 5th of x plus 1/3 secant to the cubed of x plus c. That is our solution for this next example. So in the next example here, I would like us to look at the integral of 1 minus tangent squared of x over secant squared of x dx. Now, what I want you to do is do not look over here yet. I should have made this hidden, but let's not look at this for yet. But yeah, this is going to be a mess, I guess. So right here, we've got this 1 minus tangent squared of x over secant squared of x. Now, I said we were doing tangent and secant integrals, but it's really nice to reacquaint yourself with the trig identities, and we're going to be using those. So think about this as making a proof. So we need to find something that this reduces to. I want to find something that this reduces to that's going to make it easy to do this integral, because as it stands, that integral doesn't work. So a good place to start is always to put everything in terms of sine and cosine. So we get 1 minus sine squared over cosine squared over secant squared, over 1 over cosine squared, however you want to do that. And then we combine the denominators. This gives us a multi-fraction. So we get the integral of cosine squared of x minus sine squared of x all over cosine squared of x all over 1 over cosine squared of x dx. Okay, so now we can do our keep change flip rule from arithmetic, and that gives us the integral of cosine squared x minus sine squared x times cosine squared x over cosine squared x. Now, where do you remember this from? Well, maybe you remember this guy here as one of the many formulas we have for the cosine of 2x. So if I have cosine of 2 theta, that's equal to the cosine squared of theta minus the sine squared of theta, among other variations of this. But this is important. We're going to be using this, right? Because these guys cancel out. So what we can do is we can make this the integral of cosine squared of x minus sine squared of x dx, which becomes the integral of cosine of 2x dx, which is obviously 1/2 sine 2x plus c, right? We can do that 1/2 rule pretty easily because that's, again, a mental use substitution. We can do that in our heads. That makes our lives easy. Okay, let's move on to the next one, or the last one, actually. So what I would like us to do is I would like us to integrate x times the tangent squared of x dx. Now, from first sight, we know that this is going to be an integration by parts problem. I know I'm throwing in integration by parts here, but this should be okay. So what we're going to do is we're going to pick our u and our du. Obviously, the x should be our u, right? So we get u equals x, du equals 1 dx, dv equals tangent squared of x dx. But oh wait, can we do the integral of tangent squared of x? Well, we can with a little bit of trigonometric footwork. So what we do is we integrate tangent squared of x dx as the integral of secant squared of x minus 1 dx. Because the secant squared, this is an elementary antiderivative. This is just the tangent. So this becomes the tangent of x minus x. Again, that 1 goes up to the x, but these Pythagorean identities, boy, are they helpful. So yeah, that's how we do that integral. So we get v equals tangent of x minus x. Right, so now we can plug this into tangent x minus x squared. So we are throwing all of these guys in. So you've got the you've got the x tangent x from there, and then we've got the minus x squared because we're multiplying everything by x, and then we subtract the integral of tangent x minus x dx. Right, we want to integrate tangent x. We remember this from the last video. When we integrate tangent of x, we do a u substitution, setting u equal to cosine of x, and du equal to sine of x, or negative sine of x dx. We're left with the negative natural logarithm of u. So that's the negative natural logarithm of the cosine. And you can rewrite that as the positive natural logarithm of the secant. But it's really up to you whether you want to make that the cosine or the secant. I like positive answers, so we're going to use whatever makes it a positive. So we do all this integration out. This is elementary stuff. And then this gives us the answer of x tangent x minus x squared plus 1/2 x squared. I could combine those, but I don't feel like combining these because this looks fine. Plus, we're going to use the cosine case because that gives us a positive, and I like the positive. And that gives us plus natural log of cosine x plus c. Alright, thank you for watching this video. Again, check out the daily integral playlist for more help on this, and the website for problem sets. Thank you for watching. We'll see you in the next one. We'll talk about either Weierstrass or trigonometric substitution, but I have a feeling it's going to be trigonometric substitution. We'll do Weierstrass later. Alright, thanks for watching. See you in the next one.